Starting now, yes, okay. Well, here we are, and again, there's a quote about clouds. And note that, yes, those of us with gray beards been doing this stuff for about 50 years. Things have moved, big mainframes, and we moved out to PCs, and we had some things that went, now we're kind of going back to the big mainframes. Everybody's using their phone or their laptop as a terminal, and it does very little processing now, and it's going back. Okay. Okay, we're still on unit 13. I got several slides today from Dr. Yu in our department. Okay, we're talking about cloud computing. That's a new topic. I added it. We're doing security of cloud computing. Many of you probably know more about cloud computing than I do. So if I say something that seems questionable, well, I may be wrong. So just let me know. Speak up and straighten me out. Okay, but cloud computing, basically the idea is that instead of buying your own equipment, your own, computers and stuff, network facilities, that you hire another company to do your computing stuff. That they will buy the computers, they will run them and operate them, and keep them safe, and you can just use their equipment in various ways. There are different ways to use it. We'll talk about that in detail in a few minutes. Computers cost a lot of money. I mean, this thing doesn't cost a whole lot of money. It didn't cost me anything because it belongs to the university. But yes, to buy a computer, it's not that expensive. But on the other hand, if you want to buy big computers, lots of computers, big racks of servers, that can cost a lot. And then there's, you need people to maintain it. And that costs a lot too. So also there's a large cloud service providers, which by the way, we abbreviate CSP. Cloud service providers, since they have many customers, can afford to hire experts and make sure that it runs effectively and securely. Okay, so we have this move in the last decade or so. We've been moving away from people owning their own equipment to hiring out your IT services from other companies. And there's several different models of doing that. And the big thing is that there's kind of a separation of the computing environment from the actual physical machine. You don't really know what physical machine you're running on. And it may change. It may change while you're running. It may move from this. Also, we'll talk about elasticity. So, and again, they are usually virtual machines. So you may have multiple users running on the same machine, multiple third-party cloud environments running on the same hardware, or your cloud environment might be running on multiple pieces of hardware. There's a couple of examples of cloud use that you probably use. Here at A&T, if you have a aggies@ncat.edu email address, well, that's Gmail. You probably know it's Gmail. But by the way, out of curiosity, do you get advertisements in your email? When you when you receive an email from somebody else on campus, do you see any ads? Is that, let's say we don't know.
I think so, yeah.
You do. How about anybody else? You do? Okay. Because the faculty have the @ncat.edu, which is completely separate. The ncat.edu is housed here on campus, and the students are supported by Google at Gmail. And having been here for almost 30 years, it's a big benefit. IT had a hard time running the email system. Well, it's difficult to run email for tens of thousands of people. And it didn't work well all the time. And so they sold the business to Gmail, who does a much better job at it because that's their job. They do an excellent job at it. And so, yes, you can connect to your Gmail account or your Aggies@NCAT account on the web and use it anywhere. That, of course, is Google. There's a lot of websites out there that are hosted on various cloud platforms. Amazon Web Services, well, here. Well, back. A lot of times I'm looking at the HTTP headers of things because I've been teaching security classes about spying and everything going back. And I can see indications that things are coming off Amazon Web Service servers. You see AWS someplace, that's, we know what kind of server they're using. And again, many people are supporting the web pages for big companies, but they don't own the web server. The web server is just a Amazon server. I might point out, you've probably seen, by now you should know how HTTP works. Here's a get command, and in the get command you have the where is it? Well, you have the web page, and here's my page.html, and then the required host, well, I'm going to call it option. I guess if it's required, it's not an option. The host parameter, it is required on HTTP. The reason it's required, it used to be at one point under HTTP 1.0, back in the old days when Tim Berners-Lee was thinking of this thing, you didn't specify that because when you went to the web server, well, the web server only had one site. But now with cloud services, a web server might have many websites that it's supported. And so the same physical server, the same network address, hosts multiple sites. So here we have www.acme.com at the website, but the same machine, the same web server might also support, www.widgets.com or whatever. They're both running on the same machine. And the web server, as it gets the HTTP request, looks in the host and says, oh, this goes to Acme or this goes to Widgets. Excuse me. There are a number of web service providers available in the world, in this country. Here's some of the top ones according to Google search. Amazon Web Services is up there. So is Google, Alibaba, Oracle. You might, Alibaba, for those who aren't familiar, Alibaba is the Chinese version of Amazon. Well, yes, Alibaba has an online marketing presence that's huge in other countries. They are one of the world's largest retailers, as is Amazon. Therefore, both Amazon and Alibaba are required for their business to have huge web server farms. In fact, I think Amazon has one here in North Carolina, but they're hiding someplace in some bunker. They have these big, huge web server farms, lots and lots of servers. And of course, because they have all this computing resource, they sell some of their excess computing resource. I mean, if you're doing this, so you have a dozen web servers around, web server operations around the farm, around the country, it doesn't cost you much more to have a couple extra. Just clone what you have, use them if you need to, and then sell the excess. You already have the expertise, the people to do it. You just sell that excess service. So that's what Google and Amazon are doing. And then, of course, Microsoft and Google are kind of in the business, as is IBM. They are companies that sell these things, and they don't want to be left behind. Microsoft certainly doesn't want Google to get ahead of them in anything. They've been battling it for, for several years now. And then, of course, Oracle is the same thing. They sell this sort of stuff, so they're in that business. Now, when you access cloud computing, you, of course, do it across the internet. And you should have figured out by now that there are multiple vulnerabilities in the internet. It's a dangerous place out there. And so as everything's going over the internet, you have to be a little bit more careful. Now, of course, if you're running a traditional IT where you own your own machines, if people are accessing you over the net, same threat, nothing different. But because in the cloud, it's always over the internet, then that is a concern. There are several features that people like in cloud systems you don't get for regular traditional IT. Elasticity is the concept that as you need more resources, they can be given to your application. So if your application starts doing a lot of processing, then the cloud service provider, assuming you've contracted for it, cloud service provider can provide you with more resources. If you need more disk storage space, they can provide you quickly with more storage space because they usually have extra. And so it's very easy, particularly if you have a peak period. If, for instance, you are a retailer and you rely on the Thanksgiving weekend, that's where you make half your business. You may, for those few days, need a lot more computing resources, but you don't need them for the rest of the year. Well, traditionally, you have to buy enough computing equipment to support your maximum load, which can be very expensive. With elasticity, you buy what you need and it expands and contracts. So you can get more during the heavy periods and then pay less. And also, of course, there's the pay for what you use concept, and they bill it by some metric, whatever, CPU hours, or, there's all sorts of metrics that you can bill people for. That sounds simple, having developed computer billing systems before. Computer billing is not as easy as it looks. You got to bill. How do you bill for memory and CPU time and network time and I/O time and disk space? And yes, and you put a little number in you. Okay, it's like doing your grades. Nothing counts. Okay, but people have found that there are benefits in cloud computing. There must be, because cloud computing market has expanded and many more people are using it. And again, the big reason is the initial capital expenses to go out and buy your own computing can be quite high, whereas you can just lease them, almost no initial overhead in the cloud, and you just pay for what you need. And so, okay, cover that. All right, there are several scenarios or models in which you can use cloud computing. And I'll go over these, and those experts in cloud computing can straighten me out. I'll explain each one of these, but they are typically known by their acronyms. There's software as a service, platform as a service, infrastructure as a service, and storage as a service. All four of them. The fourth one being slightly different than the others, but it is one of the features of cloud computing. Let's explain how all these work. Okay, here's a diagram to give you. Basically, the infrastructure just says, here's a machine that you can use. Do whatever you want. You can boot up your own operating system. You can reboot it if you, anytime you feel like doing that. It's your hardware. It may not be real hardware, but it looks like real hardware. And you can use it as you see fit. Run whatever operating system you want, whatever applications. And then there's platform as a service, where generally they provide the operating system and some of the basic middleware. And then you provide the applications and everything else to make it work. And then software as a service, where basically they provide almost everything, the software, the applications. You're probably running the CSP's applications and you're just running with your data and your customers. Okay, a little bit more detail here. Again, infrastructure as a service basically provides you with what looks like a physical machine. In other words, they say you're accessing it across the net, of course, but it looks like you've got the customer being the company that's using this, not necessarily the company's customer. The customer being the customer of a cloud service provider. Corporations that are using this, the corporations got a contract for infrastructure as a service, then they see on the web a machine that they can use. They can boot up their operating system on it. They can run whatever they want to on it. If they, they can configure it as they see fit. Now, there's a few underlying things they don't have access to, because there's the virtualization or hypervisor that runs the whole thing. They don't have access to that. But basically, the rest of it is under their control. Platform as a service, which is the middle layer, platform as a service says the cloud service provider is going to provide an operating system and usually some middleware. And this says programming languages. I don't know programming languages is really a good identifier. I stole the slide from Dr. Yu, but about half of them are stolen from Dr. Yu. But yeah, but anyway, they give you an environment in which you can run your own applications. You don't have to worry about the operating system. They run that. You, though, have to provide your own applications. What are you going to do with this? So you have control over that, and the cloud service provider runs the operating system in the other. Then there's software as a service. This is the top level, where the cloud service provider provides the most resources. They run the applications and you just run it with your data. An example of this would be a web server. In other words, say you were using the cloud service provider to support your website. It's their copy of the web server. Say they might have Apache web server running. They will keep that running. They'll configure it. Right? All you do is provide your web pages, all your the information. You might also have your PHP, that runs, and for things, and you have your file system. But basically, you're using their environment running with your stuff. And then there's storage as a service. Storage as a service is where you store information out on the web. It's become quite popular, not only for corporations, but for individuals. For instance, at home, I have a backup program that every day backs up my new files to someplace out on the web. I don't know where they put them, but they are storing them out there off-site. But by the way, get distracted here for a minute. Having been in the business for a long time, you need to back up your data. You need to back up the stuff on your phone. You need to back up the stuff on your laptop. Your disk drive will fail. It will break. It's just a matter of when. Now, if you're lucky, it'll be a long time, but someday it will break. Or there's many different things that can, the hardware can break, or somehow the data can become inaccessible, and so you're screwed. If you don't back it up, it's dead. So you have to back it up, and you should have at least one backup every now and again. That's away from your computer, because if you have a fire at your house or your apartment that burns down your computer, you don't want to lose everything out. Some people back it up, put the backup copies right next to them. That's nice, and that works really well until something takes out it all. Some flood comes through and washes it all away. If you have a backup, back it up someplace else. Cloud backups are good for that. Or for years, I backed up my stuff at home every now and again and brought a backup copy and put it in the lower drawer of my desk here at work. So back your stuff up. Storage systems often provide this backup, this data redundancy. They'll provide a feature that here's your data. You can store your data out of the cloud, and they will make sure that it's always there. Okay, here's your typical diagram that explains who's responsible for what. And it is the responsibility that is an important aspect. Okay, on the left is the traditional IT, where you own all the equipment, you manage it, everything, the hardware, the software, the middleware, the applications, it's all yours, all your responsibility. You have to have people to maintain it. You got to buy it all in the first place. And then infrastructure as a service. Well, infrastructure as a service, they provide you with what looks like a machine. Of course, it's typically a virtual machine, and you can run your own operating system on it, your own applications with your own data. And then platform as a service, again, they run the operating system, the middleware, and you can run your own applications with your own data. And then software as a service, the platform, the cloud service provider manages everything for you. They're responsible for making sure that all this works. So you don't have to have people who are your Apache web server expert that you might have under any one of the other aspects. And any one of these applications, though, any one of these models, the user is always responsible for the security of their data. And I'm here to talk about security, and so each user is always responsible for maintaining the security of their data. And if you are not secure, if you don't have your data protected, then that's your problem, and not much the service provider can do about that. There's another explanation I saw on the web that looked pretty interesting. Pizza as a service. So real quickly, if you make it yourself, you got to respond for everything. If you go out and buy a frozen pizza, then you have to cook it yourself and serve it while it's something to drink. But somebody else makes most of it. If you buy pizza delivered, well then it's your house, your drinks, but they provide the pizza. Of course, you go out, but in these times of COVID, it's more exciting. But you can go out, and then they're responsible for everything. So again, it's a matter of who's responsible for what. Okay, and we have a clicker question. So get out your, what was your name? Failed. Okay. So the, oh. Okay. Hopefully the people on the web can see the question, and we can see it here.
Yes, we can.
Good, thank you. Well, click away. Oh, let me get my phone. There we go. Ah. Okay. All right. Understand the question? Any questions about the question? Okay, then let's answer it. Okay, you got your answer. Put your card up where I can see it. Gotta get over his head. Okay, I see only 3 of mine. I failed. Oh, wait, I'm sorry. Oh, I got it. Okay. Yes, I got them all. Okay. We have 3 B's and a D. Let's see how we're doing here online. Okay, and the poll, and we have two A's and 2 B's. Oh, did you vote B's? Did I get that right? Everybody voted B's and D's? Yeah, okay. I kind of thought the answer was C. Infrastructure as a service. You notice you have to run this ancient operating system, IBM VMS or MVS. So your cloud service provider is not going to provide that software. They're not going to have MVS out there. And so if you want MVS, you're going to have to get it and run it yourself. So, and so I think the answer is going to have to be C. Any question about that is you're going to have to be able to boot your own weird operating system. I don't even know if anybody has a machine that MVS would run on. Heavens. Although I might mention.
Right. So, Professor, on platform as a service, like there is a, they allow you to load the operating system, right? Or they don't?
No, platform as a service here. You notice, yes, another platform as a service.
You can load your operating system, right? You manage the OS.
Platform as a service, they're responsible.
Oh, okay.
Infrastructure as a service, you run your own operating system.
Oh, okay. I just messed up a little bit. I thought one is other way. So I just like forgot. I remember this diagram, but like I switched the things.
Okay. Infrastructure is basically they just give you what looks like a piece of hardware. And you can do whatever you want to with it. By the way, that's not an unusual, this is actually a real item. Long ago and far away, I ran on a system that used virtual machines, and somebody had an application that ran on an ancient operating system. And so we booted up a virtual machine, put the ancient operating system in it, and ran their application. So it ran all the time in our hardware, and everybody else in the machine was running a much more modern operating system, except one of the virtual users running an ancient operating system, running an important application for the library. Okay, so traditionally, of course, VRAM machines, they'd boot up, they'd run up one copy of the operating system on the machine, and it'd run a bunch of applications. And of course, that allowed the applications to get the resources that the operating system can allocate that. Occasionally, some applications might get in the way of another application, particularly if one failed. Fixing it might require rebooting the system, and that would, of course, take down the other applications. So that can be a problem. Virtual machines have come out a long time. Many of you I know, well, yes, you've got a virtual machine that runs the Tune Store. Yes, so everybody knows about virtual machines. Virtual machines have been around. They've been around for a long time. Some people think they're kind of modern. Those with gray beards know better. I used to run one in the mid 80s, 1980s, system by IBM called IBM VM370. And it, all users had their own virtual machine, and they would boot up, typically you'd boot up this little interactive operating system called CMS. And the users would run that, and it would, but each user had its own virtual machine. They could communicate. Interestingly enough, you communicated by connecting the virtual machines. You could connect your printer, or actually they had, commonly was a virtual card punch. This is the ancient machine. Card punch connected to the other user's card reader. There were hypervisor commands, and you could do something like connect my card punch to the user, this user's card reader. And then once you sent something, it would appear in their card reader. That's how email worked. Email just, oh, you want to send something to somebody? The application would do these hypervisor commands, send it across, and then it would appear in the other side's card reader, and their email system would go, oh, something in the card reader. It would read it in and display it as email. And so each virtual machine is quite isolated, and they communicated through these kind of strange systems. But you could define the hardware on your imaginary machine. And again, that was the environment where we ran an application for the library by booting up an ancient operating system in their virtual machine. Okay, again, it looks like you have an emulated environment. There's also, that again is when you're emulating the hardware, which much of which we're talking about here when we talk about virtualization. There's also virtual machines that you can run to run an application, such as the Java virtual machine. Java compiles to byte codes and intermediate language, and then those byte codes are interpreted or compiled again to run on the hardware inside the Java virtual machine. There are other languages like C# also runs in a virtual machine. The advantage of these virtual machines is they can often protect the users more. You can you can protect things more than you can under like just old-fashioned C. Okay. So they're pretty widespread use. You use them in classes to give our strange and unusual programming environments. And they're also widely used even people who own their own equipment might have multiple virtual machines in their server running different applications. One application might be running the web server. They may have a DNS, domain name server, running on one HTTP, some other servers running on the same machine, each in virtual machines on the one piece of hardware. And again, the reason for doing it on virtual machines is that something gets really screwed up, you can just press the reset button and reset that virtual machine without impacting the others in any way. Again, now with virtualization, they've been able to virtualize virtual machines in servers at some other location and then sell that access to that virtual machine as the cloud. That's basically what the cloud is somebody's virtual machine running out there. Also, of course, they've gotten more advanced. Not only does it run just on one machine, but they've been able to share the load across multiple machines. Also, because they run things on multiple machines, they can be more redundant, more hardened against the failure of individualizing. If you're running on a machine and that machine decides it's going to break, that the power supply just blows up and it's not running anymore. If you have a redundant virtual machine where the cloud service provider is run over multiple machines, possibly in many different cities, then they can just reroute your activity to another machine and keep on going. And again, in other words, inevitable hardware software failures. They will break. Be ready for it. Oops, sorry. Okay, now, so much for virtual machines, but this isn't a virtual machine class. This is software security testing. So what are the security issues for virtual machines? They are in general the same, almost the same as non-virtual machines. Everything that happens in a non-virtual machine also happens in a virtual cloud system. But there are a couple other issues. Of course, everybody wants the usual things you want: confidentiality, integrity, availability, the CIA of security. When nobody wants that in the cloud environment. Oh, so here we have another question. So I'm going to run the polls here. Okay, so think about this question for a minute. Okay, those out there in the net, please click on the poll, and it looks like people here already. She's got hers unfolded. All right. Okay, let's see them. Okay, got you. Okay, I think yes, that's 5 of them. Okay, let's see how the polling is doing over here on the web. Oh, what are we done? Okay. Folks online are more diverse here. Here in class, people voted for 4 of them voted for D, 1 of them voted for C. Online, 2 of them voted for D. So we have 6 votes for D, 2 votes for C, and somebody voted for A. Well, that means a bunch of you are wrong, right? And that's an obvious. I think I just said that. That's an obvious fact. I kind of thought the answer was C. Always uses virtual machines. Well, not necessarily always. By the way, students, you see the word always in a multiple choice, it's usually wrong. You're taking multiple choice for now, you know that, it's not right. So always, no, because again, the web server example. No, we're not always necessarily using virtual machines. There may be one hardware machine with multiple customers, multiple websites. Used by corporations, but not usually by individuals. Well, storage as a server is a cloud server that's used by individuals. Again, I use it myself. Generally support multiple users of a machine. Yes, that is true. And typically, of course, students click on all the above if there is there, but this way I just put that in there to fool you. So no, okay. All right, questions about the questions? Everybody got it? All right, so moving on, where is that? Okay, so I thought this quote that I found at a particular website from Tech Target pretty much summed up the issues for cloud security. Where cloud security differs from traditional cybersecurity is in the fact that administrators must secure assets that reside within a third-party server provider's infrastructure. That's really the big issue. You don't own the equipment. There's someplace else, but your business is just, the life of your business depends on something that somebody else is doing. And again, depending on the model, depends on how much responsibility one side has to the other. But if you're, say, using software as a service, you're depending an awful lot on the cloud service provider to keep this thing secure in an environment that you don't control most of it. Then it also involves people at the cloud service provider can have access to your data. That can be frightening for some companies. They don't want anybody to have access to their data. Now, of course, there's always the insider attack from your company, but now you can have an insider attack from your company or the cloud service provider. And well, certainly cloud service providers try to maintain an honest, good reputation, being honest and nobody messes with anything. It can happen. I might mention that encryption can help protect your data. It's not an absolute, because depending on how that works, it may be possible for the people at the cloud service provider to get by that. But encryption does help protect it a lot. Again, they usually say that encryption should be used your data at rest, your data in transit. There's the third one, I can't remember. Who else read that? Well, just encrypt it all the time. Okay, here are some other challenges, but the same website had this. Some of these are more cloud oriented than others, but some of them also seem to exist in non-cloud environments. Cloud account hijacking, that is, somebody finds out your account and can access it. But also, of course, somebody can find out the account information from the cloud service provider and do something. Lack of cloud visibility and control. Again, because somebody else is managing it, you don't see everything that you might see if you were running the system yourself. The cloud service provider is going to provide you with security tools. Now, of course, they have security experts. And so on the positive side, they have experts who probably know more than your in-house people do about keeping it secure. And they provide security tools, but your people may not necessarily know how to use them. So you have to rely on these tools that you don't necessarily know. They track the data, monitoring it in their way. Okay, again, challenges in understanding who's doing what. Here's a diagram I got from Dr. Yu about security challenges for cloud. So we have our cloud there in the middle. You've got external threats. And those are pretty much the same as anybody. They're threats from somebody else. You've got the cloud management infrastructure there at the bottom, and you've got threats from the guests. The guests, of course, are the applications running in the cloud environment. The cloud management infrastructure is the system provided by the cloud service provider, and the guest could attack that, and that could attack the guests. And it's even possible for one guest to interfere with another guest. External threats coming in, they're pretty much the way it was in non-cloud environments. And so they're basically external threats are attacking from someplace else that's not another cloud guest. Then there's guest to clouds. That is, the applications doing something to the cloud and trying to do that. So it may be possible the guest to do something that interferes with the actions of the cloud infrastructure. And of course, danger is that if the guest does something that damages the infrastructure, that they'll take down the system, and not only their running, but all the other users may be impacted. Again, if they're using virtual machines, and most of them are, there is a virtual machine image, just like you have for the virtual machine you use for the tune store. There's a, well, if the attacker can get access to that virtual machine image, they can change things to do whatever they want to release your data in some way, or to change your application. So it's important, of course, that the cloud service provider keep those secure. This is actually, it's listed as a guest to cloud threat, but it's really a guest to cloud or an external access. Somebody's impacting the image or the virtual machine. And such things are, some places we call them hyperjacking. Click jacking, this jacking. Okay. Again, cloud guest threats are basically where we have an untrustworthy insider in the cloud using it, or we have, yes, that's basically where somebody working for the cloud service provider is doing something to a guest to interfere with their operations or to spy on their data, to copy or destroy the data. Insecure interfaces and APIs is a danger for cloud and non-cloud applications, but because everything in the cloud operates this way, it becomes a little bit more of a threat, because all access is through APIs across the web. That gives a little bigger exposure. Oh, I got another clicker question here just to keep you awake, for those who are falling asleep. And so we will try this one. Oh, stop sharing. Sorry, that's on the way. Okay, there is the question. It's pretty simple. It's only two possible choices. And it can't be all of the above. So, okay. Ready? Let's do it. Put your numbers up there. So, ooh. Oh, yeah, hang on here. Come on. Ah, sorry. There we go. Oh, I gotta put up them up so I can see them. Okay. Yeah, I think I got them all. Okay, let's see. 5. Yes, they got them all. Okay. And here online. Okay, the results online are different. Here in class, I got 4 B's, 4 falses, and 1 A. And online, I got 3 trues and 1 false. Mixture. Well, I kind of thought the answer was A. Almost everything that you can do to a traditional on-premise system, you can also do to a cloud system. And then there's more, so it's not only do you have the usual stuff, but there is more. So I think the answer I was going for was A. Mind you, by the way, that I don't grade any of these things. I have no idea who you are on my machine because, I don't know what card you have. Although when I put this up, it does tell me what card you are. The little box pops up telling me I can see it. I don't record who it is. Okay. Okay. Storage as a service. Again, storage as a service has greater risk than having your own storage. Not, well, greater risk than other things. But if you are using a cloud storage system, your data is at somewhat greater risk than if you just had a disk drive on premise next, connected to your machine. Because if it's connected, inside the box, well, then it is not going anywhere. You know where it is. If it's going to a cloud service provider, it's going across the network. By the way, I didn't even mention it. To be effective, this requires you to have a high-speed network. You should, dial-up modem is not going to do it. You're just going to have a high-speed system as fast as you can get. And again, depending on what you're doing, if it's just displaying web pages, it's not a problem. If you're relying on the application running at top speed to be able to access the data across the network, then you're going to want low latency networks. Now, the positive side for storage as a service, again, the CSP has a lot more, has personnel that can be dedicated to this. They understand the system. They probably have more people working on the storage than you do in your own environment. And typically, they're also responsible for backing it up. So if you're going to put your data in the cloud, kind of the agreement is that you put it there, they'll keep it, and it'll be there when you want it. So if something breaks, if one of them, this drive just explodes and pieces scatter across the room, they will resolve that and be ready to keep on going despite that fact. And that's not an issue that you have to worry about. This is not a cloud issue. This is the next 3 slides I dug out of some other class where I talked about backing up your data. I want to point out how do things get destroyed? Well, there's all sorts of ways you can lose your data. I mean, there's many, many ways you can lose your data. One is user error. It's the oops factor. It's probably happened to you. You press that button, and milliseconds later you realize, oh, I shouldn't have done that. But you did, it's gone. Disk failure, that's when the machine, of course, breaks. Data corruption is where the hardware still seems to work, but the operating system can't seem to find your can't find your files. It's also the OS. Your OS can crash and not come back up. Power failures. In most systems, your data is cached to the RAM of your machine. So if you write something to the disk or to a disk file, it stores it in RAM and then writes it to the disk when it has the opportunity. It doesn't write it right away, and that makes the things run much, much faster. But if you pull the plug fast enough at the wrong time, there could be data in the RAM that will get lost when you pull the plug and never get flushed back to the disk drive. And of course, all sorts of natural disasters can come by and destroy your equipment. Malware, people can do nasty things, and somebody can steal it. You know, your laptops, people can steal laptops, and that happens a lot. Here's a chart I got, that's just a couple years old, on what causes errors. Well, you can see right down there at the bottom, 31% of the data loss is human error. 41%, which is a little less than half, is hardware failure. Everybody thinks, oh, your problem is if your disk breaks. Well, that's not the whole thing. Software corruption, which to a user, you know, could be just as bad as hardware failure, but software corruption is where something's going wrong and it no longer finds your data. You know, the system reports all sorts of problems when you're trying to go for it, or maybe the system doesn't boot up. Malware can be pretty big. Now, that's why we have these classes, because system security is a real threat. 7% of the data loss is due to malware. Another 5% was somebody just stole the whole machine, or at least the disk drive. And then natural disasters are 3%, but not to be overlooked. Natural disasters do occur. I guess we're supposed to believe because of global warming are happening more often. Just it looks that way at least. So yes, you have to be aware that these things will happen, and you have to be ready for them. Again, off-site backups are required. You have to consider what is the value of your data. For many companies, the data is everything. If you lose your data, well, you're dead. If you're a software development company and suddenly you lose your source code to the product that you sell, well, you must just, you know, time to quit. It's gone. There's nothing. So you have to keep your backup. Losing it can be trouble loss to the company. And then again, because if you look at that data, you'll see it's less probable that somebody else will destroy your data than you lose it by yourself. Or yes, was it 7% by malware, 31% by yourself. So it's much more likely you'll do it to yourself than somebody else will do it for you. So of course, this is a security class. We're supposed to think we're here to protect ourselves, but yes, we have to also protect ourselves from ourselves. And that's what backups are for. Those things happen. You should be ready for it to happen. Okay, that's what I had for today. Still didn't make my full hour, 15 minutes, but you know, if you don't like it, you can stay out. I do want to make one other announcement here. I'm tired of sitting in front of my camera from 4 to 6 on Thursdays, looking at myself, nobody there. So we're going to change office hours. If you want to talk to me about the class or about anything, just text me or email me or send smoke signals or something. And we can talk on the phone, or I can set up a Zoom meeting, whatever you like, anytime you want to, assuming, you know, yeah, any reasonable time. I'm an old guy. I get up dark and early in the morning. Used to get up and go running at 5:55 in the morning. So that means I don't go to. That means I don't stay up late at night. So yeah, it's after 10. Forget it. Okay. Now, if you want to set up a meeting to talk about a topic, and you say, "Boy, I just don't understand that project question." How do you do that? You want to talk about it, do it. I will send a message out to the entire class telling them we're going to talk about it at a given time. Unless, of course, you don't want me to. Then I won't. But typically, if, somebody, you know, Fred calls up and wants to talk about problem 7 because they just don't know how to do it, sure. We'll Zoom and we'll share screens and we'll talk about problem 7. And I'll tell everybody else that we're talking about problem 7 at whatever time, and you're all welcome to join in. Unless, you know, Fred thinks I'm being cruel to him and just wants to bark at me, that's fine. I won't invite everybody else. Okay. All right, so that's it for today. On Monday, we will be talking about the topic that was going to be in today. Let me stop my recording. Excuse me. Stop recording.